Hey, sixth graders. So today we're going to be learning about weathering and erosion. If you haven't done so already, you should take out your weathering and erosion notes, which you should have already set up. And we're going to go through this together. I'm going to probably go a little bit faster than I normally go, just because you always have the opportunity to just pause this video and stop to write it down before I keep going. So I'm not going to always give you that time to write it down, just so you know. So we're going to start with our first definition here, which is weathering. It's the breakdown of rock into smaller and smaller pieces. This can happen in kind of a couple different ways. One way is to just somehow the rock gets smashed and then little pieces break off. Nothing physically changes about the rock. It's just a smaller version of that rock turns into pebbles or sediments. Or it can go through some kind of chemical reaction, maybe come into contact with some kind of an acid that wears away on the outside of the rock as well. And it could just fundamentally change what the rock is through a chemical process. If you look over here, this is a picture of the Devil's Tower, which is located in Wyoming. I'm going to go to the next slide here so you can see a better picture of it on the bottom right. So there's Devil's Tower, Wyoming. This is what it looks like today, but we think in this image over here that volcano that's posted above it, that's what it used to look like millions of years ago. And then over time, it's no longer volcanically active. It has weathered and eroded away to the look that it has today. So the Native Americans gave it this name of, it was mistranslated at the time as Good Bad Tower. So that became, or Bad God Tower. So that became Devil's Tower. But really they call it the Bear's Lair. And you could see they just imagine that those big like marks on it were the result of these gigantic bear claws. And they had this story of like the Native Americans on top of the Devil's Tower fighting it. So that's a pretty cool image on the bottom left there. So weathering is the breakdown of rock. We talked about that. One of the main ways that this happens is water. We're going to get into a couple different ways soon. So namely, rain would be one way, right? That's like chemical weathering. And then there's also the mechanical weathering of ice wedging that's taking place here. We'll learn a little bit more about that soon. Erosion's a little bit different than weathering. Erosion's not actually breaking it down. It's carrying it away. So this is a removal and transport of material, and this can be done by wind, water, or ice. We'll first start out talking about wind. So you can see here as the wind picks up this grain of sand, and then it gets too heavy at that moment and then drops back down, but it keeps on moving. All these grains of sand causes up this wind direction, builds up a slope, and this is how you get dunes here in the sand. So as I pivot over here for a quick second, we're going to take a look. Hopefully this GIF is working for us. And you can see a really cool example of this taking place. There's a nasty sandstorm for you. So other than wind, obviously water is one of the ways that erosion can take place. So you're going to see in both of these cases evidence of erosion and weathering, right? Because the weathering is what's carving this away. Like most likely the waves are carrying particles of rock, and that's what's actually eroding away, as well as the wave action that's pounding against it. But it's also then carrying away the new particles that are getting eroded off of that. It's getting carried away to a new location. So we can see two different examples of rocks that have gone extreme weathering and erosion in this picture right here. And then the last one is ice. So if you look on the top left, continental glaciers, they no longer exist, but they used to be all over the place during the Ice Age here, has sort of flattened out this whole landscape. So they think these, some mile-high glaciers, were slowly moving their way along in North America, just flattening out different landscapes. You could see over here in this area that generally these mountains probably created the path, or the glacier moved right through here, carving in that area, and it went downwards. You can actually see in certain places, this is in New York over here in Central Park, and you can see these striations or these lines in the ground, and that comes from the glacier, which is on top, carries those pebbles and rocks on the bottom and scrapes along, digging in those deep striations. So the glacial striations are sometimes called glacial grooves, and I bet some of you are thinking this sounds familiar, and that's because this is one of the pieces of evidence that Alfred Wegener had for his theory of plate tectonics. And then we see some examples here of modern day glaciers moving right now, and you see as they melt and fall into the sea, they're also dragging those rocks underneath with them, right, and then eroding away and weathering away at the bottom. The next thing I'm definitely going to ask you to write down this definition is ice wedging. So ice wedging is when water seeps into a crack in a rock, right? So this happens during not below freezing temperatures at first. So at first it just rains and the water is left there and it fills up this gap like right in here. But then overnight when the temperatures plunge, it freezes and that wedges open or pushes open the side, and now it's a bigger opening, so more water will get in into deeper cracks, and that continues to push it aside. I'd like for you to draw this diagram right here underneath your definition of ice wedging. So here's your water that seeps in, and then overnight it freezes into becoming ice. So I'm going to skip ahead, but I'm assuming that you already drew that. Here's some more examples of ice wedging taking place. You see how it can open up in lots of different directions. Open it up, and here's a real life example. Another definition I'd like for you to write down is abrasion. This is when rocks and sediments grind against each other and it wears away exposed surfaces. So here we see an example of a cinder block right here, right? And these are all fresh cinder block, really sharp edges. And here's one that wound up on the beach after tumbling through the ocean. So it's this rock that was being pounded away against the other rocks that gradually wears away on the outside of it. So that's one example of abrasion. Here's another example of a bunch of bricks that was taken off together, very similar to sedimentary rock, like being cemented together. And this is the result of it, also tumbling in the water. So here's the waves crashing on the rocks, slamming little pieces of rocks into it that it's carrying away, like little pieces of sand that weathers away at the side. You see the rock here smoothing over the stones over here. All examples of rock grinding away against rock. Over here, this is how rivers can carry different amounts of what they call loads. So on the top over here, it's called the bed load. This is the part of the rocks are at the bottom. You don't need to write all this down, by the way, this extra information. Then you have the suspended load. These are the lighter particles that are being carried in the middle. And as long as it's a faster moving river, it'll keep those in the middle. If it's a still river, it'll all sink down to the bottom. And then this is the dissolved load. It completely mixes into the river, and you don't see that stuff at all. So we talked about that with chemical sedimentary rock, how some of those can be completely packed in together. And then over time, parts of the particles get dropped off over here, and it curves these rivers. It can wear away on the outside, and the rivers change their course over time. And I'd like for you to now pause and watch this video, which should be attached at the bottom, and you're going to see how the rivers can change over time. So you can see here on the right, this is a much younger river right here, right? And you can see the waterfalls. And because of that extra gravity falling down, it has a lot more erosive energy. Whereas over here, this river is on a nice flat plain, so it's much more slowly moving around here, and it's going to have less erosive energy, right? So that that load is going to be mostly at the bottom. It's not as murky. Over here, may be hard to see, but this is still a younger-ish river. It's called a mature river, but it's not as old as the old river over here. And you can see how muddy and dirty it is. So that's because there's a large amount of the suspended load in the middle. Whereas over here, this is a much older river, and you can actually see once upon a time it followed this path over here. But it was such a long path. Once this part just connected over here through more erosion, it's now just having a straighter path. And now this part, this, I believe, a billabong, they'll call it, will start to dry up. I'd like for you to pause now and watch this video, which is going to be the second video attached.